Hello, good day everyone. Once again, this is Professor Roger Flores of the Department of Electrical Engineering of Central Mindanao University, the professor of this subject ES 219 for the masteral students. Today we are going to discuss the next chapter of our subject, which is chapter number 5, which is entitled Statistical Quality Control. Okay, so just to give you an overview of this subject, here we're going to discuss maintaining the quality of our product or our output, no? So, depende po sa produkto natin, it is either services or goods, no? The tangible or an intangible output or product. Okay, so we have to, as we discussed in chapter 4, the total quality management or TQM. We should have to maintain the quality of our product or our output, our services, if we offer services to our clients or customers, or our tangible material output, no, as our product. So we should have to maintain so that we'll be able to maintain also our good relationship with our clients or customers. Okay, so we have this chapter number 5, the statistical quality control. Okay, to start with, we have this statistical quality control or SQC. It is the term used to describe the set of statistical tools. So what are or what will be the statistical tools that we are going to use to evaluate our product, no, or services? So used by quality professionals to evaluate organizational quality, or even in an academy we have also this quality assurance, and they have several systems to evaluate our performance, no, in an academy, no. So that is why we adopt this ISO system to for of course it is because of the qualification and the standard of this ISO, which is based on international standard also. Okay, so that is SQC, Quality Professional to Evaluate Organizational Quality. Okay, so we have these three categories of SQC. First category, we have this descriptive statistics. Okay, there we are going to determine the mean, the statistical mean, the standard deviation, because of course we should have to understand that in a study, in evaluation, then we should have to experience deviation also. So we have that standard deviation, how we are going to determine this one, and of course the range, no? Okay, then number 2, we have also the acceptance sampling. Okay, when we say acceptance sampling, this is based on the acceptance of the standard given to us by our customers or our clients, no? So used to randomly inspect a batch of goods to determine acceptance or rejection by our end users, no? The customers or the clients. We have to determine how much or percent or of course the statistical acceptance and rejection or statistical percentage of the acceptance or rejection of our goods and products or our services. Then we have also this statistical process control or this SPC. So here we are going to determine through samples, through computations, the data that we'll be able to determine or feedback information or data from the end user or any other concern when it comes to the production of our output. Okay, so we mentioned a while ago about mean. Okay, to compute the mean, we simply sum up all the observations and divide by the total number of observations. Okay, so for example, for a certain variable, we have, for example, 10 observations, no? So we have to sum up the equivalent quantitative value, the quantitative value or a number, or of course a number that we are going to use in the computation, no, equivalent number that we're going to use in our computation. Sum up all these observations, then divide it by the total number of observations. Okay, so for example, you have 10 observations, divide by 10. So that is the statistical mean, how you are going to determine the statistical mean. Okay, so we have also this formula. Okay, the x bar is equal to the summation of your x sub I, where your I is equal to 1, then up to n, the number of observations, where n here is the number of observations. So this is how you're going to determine your mean. Okay, that is the formula. So just the summation of all the observations divided by the number of observations. That is how you're going to determine the mean. Here we have this range, no? Range, which is the difference between the largest and the smallest observations. Okay, for example, if the observation is composed of this number, okay, given 3, 4, 6, 7, 9, for example, so the lowest or the smallest observation is 3, the highest is 9. So by the way, just to emphasize that sometimes this observation will not be arranged in from largest to smallest, or from smallest to largest, but sometimes they will be rearranged, no? So we just have to determine the smallest and of course the largest observation. For this specific example here, as it is shown in this given example, we have the smallest here is 3, the largest is 9. So therefore, the range of our observations is 6. Okay, that is our range, no? So that is how you are going to determine range from largest to the smallest. So we have to subtract the largest observations and the smallest observation. So the difference of these two will be our range. Okay, we have also this standard deviation. So standard deviation is a measure of dispersion of a curve. This curve is usually given in it is in a normal curve, no? So that is the statistical curves that represented by this dispersion or distribution. So whatever measure of this dispersion will be your standard deviation. It measures the extent, no, the extent to which these values are scattered around the central mean. Okay, so this is the formula of sigma, which is the standard deviation. Okay, so it is we have this symbol sigma here. It is the square root of the summation of the x minus x bar, okay, quantity squared, where your I is equal to 1 to n. So this x here is, as we know, this is the mean, okay, the number of observations. Okay, x bar is the mean of the mean, which is the summation divided by number of observation. Then x sub I here is the observations. Okay, so where your observation is from 1 to n. Okay, so depende po sa number ng observations natin. This is the formula, no? So to determine the central mean, or the central mean, which is the sigma. Okay, so talking about the statistical process control, which is the most important in the evaluation of our product, is this is a widely used sampling technique which checks the quality of an item which is engaged in a process. Okay, so the quality of an item engaged in the process. By the way, talking about the item here, so it could be a tangible, the product, or the services, which is intangible output or product that we will serve to our customers. Okay, so species also can also be used to inform management to improve process changes. Okay, that is according to Krajewski et al. 2010. Okay, so this is also an input for the management to what to do for to improve the performance or the production, the performance, the quality of the output of our product. Okay, so it will serve us, so it will help us to have this what we call as a decision making process. Okay, so it identifies the nature of variations in a process. Okay, so species also will determine the nature of the variation. Okay, so whether it is chance causes or assignable causes. Okay, so later we will discuss what is the chance cause or what is an assignable cause as the result of our SPC or statistical process control. Okay, so every time we are going to analyze a variable, then we have this, or it is sometimes or most of the time represented by a normal curve. So this is the representation of the normal curve. This is the maximum, highest, and we have this minimum, okay, the positive minimum here, and we have the going to the negative minimum or the positive minimum here. This is the central, no, the central of the curve, central line. Okay, this is what we call as normal distribution or the variation, which is most of the time represented by this normal distribution. Okay, this is going, okay, so going to the left of the normal curve, okay, going to the left of the normal curve, which is upward in this representation here, it is upward. This is a variation due to assignable causes. Okay, pwede po natin itong tinatawag natin na assignable cause. And dito po sa going to the right, which is going downward for this representation of the normal curve, this is variation due to assignable causes. Okay, so this is the center, the variation due to normal causes here at the center. Okay, so this is just the representation of the normal curve of any variation of a given statistical analysis. Okay, so as I've said a while ago, we have to discuss about chance cause or causes of variation, chance causes of the variation. So it is the process that have some inherent variability due to some unavoidable factors. Okay, some unavoidable factors, meaning to say it is beyond our control, that we cannot, any factors that we cannot control or we cannot avoid. Okay, such as ambient temperature, okay, wear of moving parts or slight variations in the composition and characteristics of the material that is being processed. No? As we know that every material will have its own characteristics. Okay, especially even metal. No, metal could become loses its strength, especially if it is heated. Okay, so that is the one of the characteristic of the metal, or any other material. No, that they will be affected by the temperature. Okay, some of these characteristic of materials will be affected due to, or there will be a variation of the performance or a feature or characteristic of this material when it comes to temperature or any other moving parts. Okay, so there will be some variation when it then because of this, because this is unavoidable. When we say unavoidable, there should be a change. If we will do something about this, maybe we cannot eliminate this variation, but only we can minimize. Okay, so ganon talaga, no? So kahit anong gagawin natin, especially for our materials, no? Especially if these materials will be exposed to a very high temperature, so wala tayong magagawa. It will affect the strength of that material. So That is why this is some of the example of these unavoidable factors, which will result to chance cost. Okay. Then it will behave in random manner. Okay. That sometimes it will behave in a random manner, and the variation is not due to defect in material or a machine, but it is due to the characteristic of this material that will affected due to the temperature, for example, and the other factors that we cannot avoid in the system. Okay, this is negligible sometimes but inevitable. Okay, so pwede natin ito mag-neglect, pero andyan yan. Hindi yan mawawala. So, of course, that will be the cause of having differences or having yun pong hindi natin talaga maa-attain yung tinatawag natin na ideal because of this, no? So anyway, that is chance cause variation. Now, the techniques of SPC involves calculating the limit of this chance cause variation for a stable system is so any problems with the process can be identified quickly. Okay, so the use of this SPC technique, okay, this chance cause of variation can be quickly determined by the system or by the evaluator, the quality control. Okay, so the limits of the chance cost variations are called control limits. So we have these control limits. We have the upper control limits, and then we have this lower control limits. Okay, so of course, this is what we call as control limits, and are shown on a control chart. Later on, we will discuss all these things, which also shows sample data of the measured characteristic over time. Okay, so there are control limits above and below. So yun po sinabi ko po kanina, I just mentioned a while ago, no? So we have this UCL and we have this LCL, the upper control limit and the lower control limit. Okay, the target value of the measurement. Okay, so we should have to determine the target value so that we will know that the performance, the quality of our products is within the curve, the upper and the lower control limit. Otherwise, if it is beyond, okay, beyond this lower or this upper limit, then we should have something to do. So we have this, we have to set control limits here. So we have this mean of 68%. Then we have here, we have the 95% or 99.7% at this point here of our normal curves. Okay, so these are the points of observations. Then we should have to determine the average of these points given to these different observations. Okay, so the behavior of the process observed by studying the control chart, and if the sample data plotted on the chart, it shows a random pattern. So yun po, mayroon po tayong tinatawag na random pattern within the upper and lower control limits. Then the process is, tinatawag po natin itong in control. Okay, so if it is within, no, within the upper and the lower limit, then we have this what we call as in control. Okay, in control process. Now, however, if it goes beyond the upper or the lower limit, then yun po ang tinatawag natin na out of control. So, of course, it is just an opposite. Okay, so within the normal curve, it will be in control process, but beyond the normal curve, that is out of control. So, as I've said kanina po, pag mayroon po tayong ganyang mga data, then we should have to do something to correct it, those erroneous performance of our product or our process. No? So, as you can see here, we have this okay, so we have this 6 observations here. Okay, with this simple representation, we have these 6 observations. But as you can see here in number 6, That is beyond the upper control limit, which is 16.2. So it is already beyond. Okay, so ito po yung tinatawag natin na observation na out of control. So most of the time, researchers will not include this one anymore because of course, konti lang naman yan, neglected po yan. No? Yun po sinasabi natin kanina na neglected. So most of the time, ito pong katulad ng example na ito, binibigyan lang po natin ng observations or analysis will be these five observations, because these five are within the lower LCL and the UCL, which is 16.2 or which is 15.8 to 16.2 respectively. Okay, so next, let us discuss about assignable cause or causes of variation. Assignable causes of variation. Okay, this is a variation in the process which is not due to random variation but can be attributed to some change in the process which needs to be investigated and rectified. Okay, so that is very clear, no? So that is assignable cause of variation. Yung mga variation na hindi po ito random variation, no? Pero it really changes the process of producing our product or our output, no? And it should be rectified later to determine, after determining the cause of this variation. So, yun po, tinatawag po natin itong assignable causes. We have two types of error which can occur when sampling from a population. So, we have the type 1 error, no? It is indicated from the sample output when none actually occurs. Okay, yung it is not actually occurs during operation. So it will cause error because it will tend to change the processes. And of course, you have type 2 errors in which an error is occurring but has not been indicated by the sample output. Okay, so these are what we call as the two types of assignable cause of variation, which are the errors. So, as we said, type 1 error here may lead to rectification work. Okay, so kailangan then we have to rectify. We have to mayroon tayo talagang gagawin para you have to correct all these errors, no, which is unnecessary, and even the unnecessary recall of faulty products. Okay, so halimbawa, yung mga produkto natin lumabas na sa merkado. Ngayon pa natin nakita yung mga errors niya na kailangan natin i-rectify. So, we should have to recall all these products. Okay, so minsan nga nangyari na yan sa mga sasakyan, di ba? You might hear that there was a time that mga cars na mayroong problema sa performance ng of course, the performance, the braking system, sa machine, sa temperature na makina. Kaya doon na nila nakita doon sa after the distribution in the market. So, ang ginagawa nila, so they have to recall all this product to check, to rectify, to solve the error, the performance of the problematic performance of this car. Okay? So, type 2 here will lead to defective products as an out-of-control process which goes to unnoticed. Okay, so when we say defective products, then of course, scratch na yan, garbage na yan, no? So that is the worst thing that will be observed when it comes to the performance of the product. Okay, so ibig sabihin, yung type 1 natin, pwede pa natin ma-rectify, pwede pa natin correct, no? But ito pong type 2 errors which we will be able to determine after this evaluation, di na natin pwede gagamitin itong mga produkto. So we need to pick it out, then of course garbage. Okay. So customers' compensation and loss of sales may result if defective products reach the marketplace. Ayun na po. Yung mga customer natin baka mag-demand na po sila ng mga liabilities, no? So we need compensation that may because it is the result of loss of sales because of these defective products. So we have as much as possible we should have to be careful. So that is why we have this what we call as quality control, because they were the in charge, or they are the in charge of the evaluation of our product prior to the distribution. Okay, so sa pagdala natin doon sa merkado. So, of course, if this product, as it is said here, will reach to the marketplace, then, of course, problem will come out, and it will cost money. Okay, so we have these types of control charts. Okay, so we have this control charts here, the X bar charts, and the other one is the R bar charts. Okay, so X bar charts here is or chart is used to monitor the changes in the mean of a process or the central tendencies. Okay, so determine the central tendencies, the center mean of the process. Okay, so yun pong at the center, no, from the peak of that normal curve, from the peak of the normal curve going to the reference point, that is our X bar, to determine its change, no. So the R bar chart is used to monitor the dispersion or the variability of the process. It is either going to the left or going to the right. Okay, so yun po mga cause doon, no. So mga variation. This R bar is or chart will determine the amount of this dispersion, the variability of this dispersion. Okay, so to understand this X bar chart and the R bar chart, we have this example here, no? So let's try this example. So a factory produces 50 cylinders per hour. Okay, for this LPG. Okay, so samples of 10 cylinders are taken at random. So we have 10 cylinders as the number of samples or observations, okay, to be observed, no, are taken at random from the production at every hour, and the diameter of cylinders are measured. So that you should have to know, or you should have to determine that this the amount fill in these cylinders are the same, no? We must have the same diameter. Then draw X bar and R charts. Okay, so X bar charts and R bar charts, and decide whether the process is under control or not. So we have this constant. We have this constants here. We have this n is equal to 4. Okay, so we have this E sub 2 is equal to 0.73, and D sub 3 is equal to 0, and D sub 4 is 2.28. Okay, so we have this sample data, no? So we have this sample data here. This sample data here, you have this value. We have sample 1 to 10 here, and then we have this number of observations. Okay, number of observations per sample. We have 4 observations here. So we have that n is equal to 4. And then, of course, we have to determine the mean. Okay. By the way, you have to determine, because sigma is not given, so we should have to determine the sigma, or this x sub I. Okay. So what is the sum? Sigma x sub I is just the sum of all the observations. Okay. So for example, for sample 1, we have the observations. We have this value 230, 238, 242, 250. Okay, so respectively for observations 1, 2, 3, 4. Okay, so the total, the summation of this observation is this 960. Sum up these observations here, we have 960. So to determine the mean or the X bar, so the mean is just As we said, this is the summation of our observation divided by the number of observation. Okay, so this is just the average. In other words, the average of the observation. So 960 divided by 4. So that is 240. So to determine the range, okay, so we have to determine the highest and the lowest observation out of this 4 observation. Is observed here that the lowest observation is 230 and the highest observation here for sample number 1 is 250. Okay, I hope that you can follow, no? So you have the 250 minus 230, that is 20. Okay, so that is why we have this 20 here as our range. Okay, for the sake of understanding the rest, no? So for sample number 2, we have 220, 230, 218, 242, and 900. Yes, 240. We have only 4 observations. So, as you can see here, the lowest observation that you can find here is this 218. Okay? So, 218. And, so, ito po, 218 po. The highest is 200. We have this 242. Okay? So, 242. So, meaning to say, if you're going to subtract this 242 minus 218, more or less that is equal to 24. The sum of these 4 observations is 910. So 910 divided by 4, we have this 227.5. Okay, this is our average, the main X bar. And so on and so forth, no? So like for example, this sample number 3, we have 222, 232, 236, 240. So, ano po yung pinaka-lowest na observations dito? So, we have this 222. And the highest is 240. Okay, so we have this 240 divided by 222, that is 18. That is our range. The summation, the sigma, the summation of this observation is 930. And this sum divided by number of observation, which is 4, is 232.5. Okay, so that is how you're going to determine so on and so forth here. We have 10 samples. Okay, so to determine the total mean or the X bar is the total is 2,345.76 and the total range is equal to 196. So take note of this computed mean total mean or the X bar, which is 2,345.75, and the total range is 196. The next solution here, we will be able to use that value. Okay, so the X double bar or X double bar here, it is equal to the calculation of this X bar, no? The calculation of X bar is the summation of that X bar divided by M, the number of samples, no? So, we have this 2,345.75 and divide by the number of samples, which is 10 samples, then we will have this 234.57. Okay, so that is our X bar. Then, for our R bar, that is the summation of our R divided by the number of samples. So 196 divided by 10, that is equal to 19.6. Okay, so assuming that we have this value of the factor that we have, the X factor of X value, no? So try to use this one, no? So like for example, if we have sample size is 10, your A sub 2 is 0.31, your D3 is the factors for our chart is 0.22, and the D4 is 1.78. Try to use this the factors, no? for the X chart, the A2, D3, and D4 for the R chart. Okay, so we have this 10, no? So we have this 10 sample. So we have this 10 sample. Okay, so we use this A sub 2 equal to 0.73. Okay, so to determine the central line, which is CL, that is equal to the central line, the X double bar is 234.57. Okay, so your X bar here is 234.57. Your E2, as it was given in the problem here, okay, so this is your E2.73, D3 is 0, D4 is 2.28, for N is equal to 4. Okay, so for N is equal to 4, so ito po, sa table natin, your N is equal to 4, your E2 is 0.73, your D3 is equal to 0, and your 2.28 po yung D4 natin. Is it correct? 2.28. Bakit? Ano po nangyari dito? Yes, 2.28. So, ito po yung mga factors na ginagamit natin po. Okay, if we have this sample size of 4, no? Observations, in other words, the observations of 4. Okay, so substitute, this is the formula to determine the upper control limit. We have the central line, at the center of the normal curve. You have that E2, and we have that our E2 here is constant for 4 observations. We have 0.73, and our R here is equal to 19.6 as we determined in the previous solution. So just to simplify, your upper control limit is 248.88. The lower control limit is almost similar solution that we have, only we have this minus here, no? You have the X bar, the central line, then minus the constant E sub 2 for 4 observations, then for the solution or derived R, okay, which is equal to 19.6. So, the lower control limit is 222.26. Okay, so ito po, no? So, more or less 222.6. Okay, 222.26. Somewhere here, no? This is the lower limit, control limit, or the upper control limit is equal to 248.88. Okay, so this is 248. Okay, so almost 250 na po yan. So it is represented by this one, the upper control limit. Okay, so this is the X bar chart. Okay, for the R bar chart, no, to determine the control limits of the R bar chart, then we have the central limit of R is equal to 19.6. Then the upper control limit is just D4 times the R, or our D4 as it is given in the factor, tabulated factor, that is 2.28. Then our R is 19.6, more or less. For our R bar chart is 44.69. That is the upper limit, and because D3 is equal to 0 for the D3 for the 4 observations that you have, then that is equal, your LCL is your 0, the lower control limit is 0. Okay, so we have this one. This is the lower control limit is equal to 0. More or less, our upper control limit is 44.69. So that is more or less nearest to 50, no, or 40.5, or that is 44. Okay, so it is drawn in this proper graph here. This is the R graph, no, R bar chart or R bar graph. Okay, so another example here in which sigma is given. So the sigma is given, no? So this is a quality control inspector of the Coca-Cola soft drink company has taken 25 samples. So we have 25 samples with 4 observations. So still we have 4 observations, no? Mayroon po tayong 4 na observations, but our sample is or having a total of 25. Each of the volume of bottles filled. The data and the computed means are shown in the table. If the standard deviation of the bottling operation is 0.14 ounces, so that is your sigma. Okay, use this information to develop control limits of 3 standard deviation for the bottling operation. Okay, so this is we are going to determine to determine our X bar chart. Okay, so this is the data that we have. We have 25 samples. We have 4 observations. Volume in ounces, no? So volume, the sample, the observation here is given by volume of that soft drinks, and then the unit of that volume is in ounce. Okay, so if you're going to determine the average, the X bar, so again, take the average of these 4 observations. We have this 15.91, and also the range. So determine the smallest. Maybe your smallest here is 15.83. Okay, so our smallest is 15.83. This third observation, and our largest value of our observation is 16.02 ounces, the highest. So 16.02 minus 15.83, of course, more or less that is equal to 0.19. So on and so forth. Okay. So sum up the average, we have 398.75. Then sum up the range, we have 7.17. Okay, so this is the sigma given here. Okay, so by the way, we will be able to solve the sigma of the observations, okay, or the X bar, no? So that is equal to determine the upper control limit, we have the X double bar plus Z, then the sigma sub X bar. Okay, so where sigma sub X bar is your S divided by your N, where your S is equal to the R bar divided by the constant of the observations D2. Okay, so D2 here is 0.73, I think, no? So this is also given from the tabulated factors. Then LCL here is just the X bar, the mean, the average of the mean minus the Z times the sigma sub X bar. Okay, so your X double bar is the summation of your the sum of the observations divided by number of samples. So we are more or less X double bar is equal to 15.95. So that our control limit is will have this equal to okay. So we have this X plus this one, we have this X double bar is 15.95 plus our Z is 3. Okay, then we have this 0.14 over the square root of 4, or the square root of number of observation, and your S is 0.14. Okay, so that is 16.16. Okay, so we have this the lower control limit is equal to 15.74. So based on that central line or central control or center line, no, center line, which is equal to 15.95. So we have this 15.95, no, and then the lower limit is we have here 15.74. So somewhere this is a 15.74, and the upper limit, which is we can found here in the observation 16, is 16.16. 16. So we have this graph. Okay. Okay, so let's proceed with the control charts for attributes. So our attributes here are discrete events. No, it is either yes or no, or pass or fail. So that is how you're going to decide, no? So to determine the performance, the results of the evaluation of the quality control. So the quality control will just say it is okay, yes, okay, or no, or this product pass or this product fail. So that is our attributes, the results of our observations or evaluation. Use P charts for quality characteristics that are discrete and involve yes or no or good or bad decisions. Okay, so number of leaking caulking tubes in a box of 48, for example. Okay, so mayroon po tayong naglilik. So it is either mayroon o wala, yes or no, or is it good or bad? Ano? Number of broken eggs in a carton. Okay, so to determine the number of how many broken eggs in a group placed in a carton. Or use C charts for discrete defects when there can be more than one defect per unit. So talking about defects, no? So we have to use C charts. So for talking about quality characteristics, so we have to use P chart. Okay, so C chart here is an example. Number of flaws or stains in a carpet sample cut from a production run. Okay, so yun, carpet here is defective. So number of stains, for example, or flaws. Okay, so we have to determine. So that is through the using this C charts. Or number of complaints per customer at a hotel. So this is another example, especially if our output is services. Okay, so we have this sample or example of C charts. Okay, so try this. Let's try this sample for P chart, or sample problem for the P chart. So a production manager of BKT Tire Company has inspected the number of defective tires in 5 random samples. So mayroon po tayong 5 random samples with 20 tires in each sample. So mayroon po tayong 20 na tire. So each tire, mayroon po tayong 5 random samples. Okay, the table below shows the number of defective tires in each sample of 20 tires, and then calculate the control limits. Okay, so calculate the upper and the lower limits. Okay, so talking about tires. Okay, so we have this table here with number of samples of 20. We have number of defectives each tire. We have 3. Number of observations, we have 20 here. Sampled, no? Then we have the fraction defective. Okay, so we have this fraction defective here, this data. So out of this data, we will be able to determine the central limit, or with this P bar. Okay, so what is the P bar or central limit or central line is the total number of defective tires divided by the total number of the observations. So mayroon po tayong total number of 40 of the defective tires out of these 20 samples, and out of this number of observations, the total number of observations is 400, no? So we have this one, 400. Okay, so that is the center line is 0.1. Okay, so for our sigma, that is the square root of P times the quantity 1 minus P bar divided by number of observations. Then we have this, our P bar is 0.1. So 0.1 quantity 1 minus 0.1, that is divided by 20. That is 0.067. That is our sigma. So of course we have this constant 3. So we have this 3 times 0.067 plus 0.1, our P, our center line. So we have this 0.301. So that is your upper control limit. the lower control limit here, LCL, is this minus, so that results to minus 0.101. Now take note that we have this minus negative value here. Then it is said here that in this example, the lower control limit is negative, which sometimes occurs because the computation is an approximation. Okay, approximation lang din naman pala itong computation natin. Okay, so we have this, we have to round it off up to the to the zero, no? Kapag mayroon tayong negative lower control limit, then we have to round it off, no, up to zero, because we cannot have negative control limit. So pag mayroon tayong negative control limit, lower limit, then we have to make it zero. Okay. So, in other words, the upper control limit is 0.301. The lower is just equal to 0. And our central line is 0.1. Okay. So, 0.1 center line. Upper is 0.067, 0.3. So, above here with 0.2. So, we have this. And our minimum is equal to 0. So, dapat meron tayong 0 dito. Okay, for the C chart sample problem, we have this example here. The number of weekly customer complaints. This is about complaints on the hotel services, no? So, the number of weekly customer complaints are monitored in a large hotel using a C chart. Develop 3 sigma control limits. Okay, so it is given here. Our sigma is equal to 3, no? The 3 sigma control limits using the data table below. Okay, so we have this table, no? So we have the number of weekly customer complaints monitored in a large hotel using C chart complaints have been recorded over the past 20 weeks. So we have 20 weeks here. Okay, total observations. Then develop 3 sigma. Okay, control limits using the following data. For the first week, we have 3 complaints. Second week, we have 2. We have third week, we have 3, and so on and so forth. So we have the last observation here is 20 weeks. Then we have 3 complaints. So total of number of weeks is 20, and the total complaints for this 20 weeks is equal to 44. Okay. So the average number of complaints per week, of course, total complaints, which is 44 divided by number of weeks, which is 20. So we have this 2.2. The upper control limit is this C plus Z, the sigma, then square root of the C bar. So that is equal to 2.2 times plus 3, the sigma, the times the square root of 2.2, which is 6.65. So the lower control limit is equal to negative 2.25. So since this is negative, then round it off to 0. Okay, so naging 0 na yan. So the lower control limit is 0. The upper control limit is 6.65. The center line is 2.22. So 2.22. Our upper limit is 6.65 here. Okay, and then the lower limit is equal to 0. Okay. Okay, so that is how you are going to evaluate our performance of the product, the quality of the product. Depende po sa gagamitin natin na chart. Mayroon tayong C chart, P chart, sa bar, R bar, we have the X bar, so that we'll be able to determine the performance of our output. So that is the work, the job, the statistical evaluation of our product. Of course, it will be performed by the quality control department or section of our company. Okay, so thank you very much, and I hope that You learned many things in our discussion today with this chapter number 5, the statistical quality control. Of course, if you learn many things so in our discussion today, please subscribe my YouTube channel and continue studying and keep safe always. And then subscribe, likes, and share our YouTube channel. Okay, so thank you very much and always keep safe always and keep healthy always. So thank you, God bless, and see you next chapter in our subject. Thank you, God bless.